Greetings everyone. I welcome you all for SAP HANA 1.0 with Support Pack 7 demo session. Before starting today's session, let me introduce myself. My name is elearnsap. I did master's degree in computer applications. I started my career as a Java developer in 1998. So I have total 3 years of experience in Java and J2E technologies. In 2000, I switched to SAP. In SAP as a ABAPer in SD, MM, FI modules. After working a couple of years in ABAP, I started working in SAP BW in 2.0B version. Later on, I worked in 3.x versions, 7.x versions. My current project with BW 7.4 with SAP HANA as well as SAP BOPI. So total, I have 11 years of experience in SAP BW, out of which 2.5 years BW with SAP HANA. When SAP acquired the business objects in 2008, from 2008 onwards, so I added business objects also to my skill set. So most of the clients who are using SAP BW, they started using SAP BOPI for their reporting requirements on top of BW. So I started working in SAP BOPI in 2008. With respect to SAP as well as non-SAP source systems. So I worked in BOPI XI 3.0, XI 3.1, SAP BOPI 4.0 and my current project with BI 4.1. Apart from SAP BOPI, my working experience includes SAP BODS XI 3.2, 4.0, 4.1, which is an EAM tool of SAP, especially in ETL point of view. So my specialization in SAP BOPI, designing the universes on top of SAP source systems up to XI 3.1, SAP BW, okay, and later on designing the universes on top of SAP HANA and report development using Web Intelligence 4.0, okay, 3.1 and Crystal reports, dashboard design, business object, Explorer, Voyager workspace, analysis session for overlap, as well as SAP Business Object Design Studio. Since last 2.5 years, I am working with SAP HANA also as one of the source for my reporting, as well as HANA as a underlying database for BW 7.3 as well as 7.4. So I have total 2 to 2.5 years of experience in SAP HANA in various support packs, including Support Pack 2, Support Pack 3, Support Pack 4, Support Pack 5, 6, and the latest one, Support Pack 7. So completed 2 POC projects, currently working with SAP HANA as with BW and HANA as a data mart projects. Total, you can say 3 years of experience in SAP HANA. Specializations in SAP HANA, business object data services with SAP HANA, developing very complex jobs for loading the data from different SAP and non-SAP source system to SAP HANA, then SLT. So modeling, designing complex information models for financial scenarios, COPA, sales, inventory, HR, CRM. Reporting using SAP BOPI 4.2 and 4.1, predictive analysis or integration with SAP HANA, decision tables with SAP HANA, HANA with SAP Lumira, backup and recovery, okay, using Business Object Design Studio for BI mobile on top of SAP HANA, and new Support Pack 7 features including Smart Data Access, SAP River as well. So I have good working experience Hadoop with SAP HANA also, extracting the data from Hadoop using Business Object Data Services, loading the data to SAP HANA, and report generation. Coming to today's demo session. So the course we are offering is HANA 1.0 with Support Pack 7, which is a latest support pack with the Data Services Workbench, Information Steward, SAP River, and Smart Data Access. Well, today's the agenda for this course is, this demo session is, first I will walk through the course roadmap of HANA 1.0 with Support Pack 7, whatever the contents we are teaching in this course. Second, HANA 1.0 with Support Pack 7 overview. Let's start with course roadmap and course syllabus. First, we'll start with SAP HANA. What is SAP HANA? In-memory strategy, in-memory computing, how SAP HANA different when comparing with traditional databases, complete introduction to SAP HANA, in-memory strategy, HANA compared to BWA, SAP HANA Studio, and SAP HANA architecture. Again, SAP HANA architecture in various perspectives. SAP HANA architecture in reporting perspective, HANA architecture in modeling perspective, SAP HANA architecture in database perspective also. So this is look and feel SAP HANA Studio, architecture in various perspectives, the architecture of persistence layer and all. So once we completed the architecture, first we'll start HANA as a data mart. What is HANA as a data mart? HANA as a data mart, the product strategy, HANA as a data mart. The client can load the data from different SAP and non-SAP source system to SAP HANA. Then modeling, designing the information model using SAP HANA Studio for facilitating the reporting requirements. Then report generation using SAP BOBA 4.0 and 4.1 reporting tools. Whenever a client is using HANA as a data mart, we can loading the data from different SAP and non-SAP source system to SAP HANA. That comes under data provisioning, then modeling and reporting. So we'll start first with data provisioning. In data provisioning, there are various data provisioning methods given by SAP as per the requirements of a client. Data provisioning using flat files. Data provisioning using BODS. This is ETL based approach. In order to build the agile data marts, for example, from a source system, the client has to load the data, but the data in the source system is not in its original shape. We need complex transformations to be performed before loading the data to SAP HANA. In that case, we can adapt ETL based approach using business object data services. In business object data services, we'll cover we'll cover most of the concepts which are required to load the data from different SAP and non-SAP source system to SAP HANA using business object data services, like business object data services 4.2 architecture, data stores in BODS, metadata, BODS objects component hierarchy, building the data flows to load the data from different SAP and non-SAP source system to SAP HANA, then query transforms and other transforms. How to use the query transforms and other transforms like case transform, validation transforms, table comparison transforms to load the data to SAP HANA, and how to load the delta data, how to achieve the CDC from different source system to SAP HANA, including business object data services. Apart from that, how to load the data from different file systems like Hadoop distributed file systems, XML files, text files, COBOL copybooks for loading the data to SAP HANA using business object data services. So after covering business object data services, we'll move on to SLT. So SLT is a data provisioning method to achieve the real-time replication for real-time reports. Complete concept of SLT, configuration, installation of SLT, and SLT based transformations, filtering the data before replication, extending the table structures, deleting the table fields that are not required for replication. So what are the transformations capabilities that are available in SAP SLT? So we'll be discussing all these things. Then there are some new methods from Business Object Data Services 4.2 is available. That is, one is Data Services Workbench. So well, this one is available from Data Services Workbench. Business Object Data Services 4.1 is a new tool given by SAP apart from Designer. So how to use the Data Services Workbench, Data Flow Editor, Monitoring Editor, File Format Editor. So we'll load the data using Data Services Workbench to SAP HANA. And Information Steward. Information Steward is a data profiling tool. Data profiling deals with checking the quality of the data before loading the data to SAP HANA. So I will show you how we can use an Information Steward for data profiling before loading the data to SAP HANA. So after completing these data provisioning methods, we'll spend some time on Smart Data Access. What is Smart Data Access? Smart Data Access is a new feature given by SAP in Support Pack 7 for loading the data from remote systems, like connecting to remote SQL Server, connecting to remote MySQL, Hadoop, okay, loading the data to SAP HANA. And at the same time, creating the calculation views using the remote data sources, SAP River. We will be covering all these other new features of Support Pack 7 for data provisioning purpose. So once we completed the data provisioning, okay, using DXC also, we'll cover the data provisioning using direct extractor connection. Then we'll move on to modeling. So the purpose of information model and modeling for different scenarios, creation of the information models for different scenarios, like for COPA scenarios, other financial scenarios, for balance sheet reports, for accounts payable, account receivable, sales order scenarios, inventory scenarios, as well as CRM scenarios. So here we will be covering very advanced level of modeling, like export and import, hierarchies, creating restricted and calculated measures, and how to design efficient information models as per the requirements of a client by following all the best practices related to, okay, illustrating all real-time project scenarios, SQL scripts and procedure, currency conversions, and creation of the very complex calculation views based on DUA method, based on other methods as well, like SQL script method. So once we completed modeling, then we'll move on to reporting, HANA reporting layer, connectivity options, then designing complex universes on top of SAP HANA tables, okay, then report development using Webby 4.0, dashboard design 4.0, how to use Business Object Explorer, Business Object Design Studio, SAP Lumira. So all these advanced reporting tools will be covered with SAP HANA as a source. So once we completed HANA as a data mode, we'll move on to how the HANA can be used as a database layer to BW 7.4. So BW 7.4 powered by SAP HANA. Okay, in-memory optimized info cubes, in-memory optimized DS4s, migration concept of BW 7.4 traditional database to, okay, on SAP HANA, then migrating standard DS4s, standard info cubes to in-memory optimized DS4s, in-memory optimized info cubes, and consumption of HANA information models in BW by creating transit providers, composite providers, importing SAP BW models in SAP HANA, okay, all these, okay, HANA related BW concept related to SAP HANA will be discussed. So after completing this, user management and security isolations. Then we'll focus more on Support Pack 7 new features like Smart Data Access, SAP River, and other new features of Support Pack 7. Then we'll look into advanced topics like predictive analysis, okay, or integration with SAP HANA, as well as Business Object Design Studio. So for every topic we'll be covering in this course, we'll be having the hands-on and the case studies, end-to-end case studies, some POC projects. So you can look at the projects will be, and the POC projects will be offering as a part of this course. Okay, designing SAP HANA tables for sales, finance, and inventory. Okay, then loading the data from different source systems, SAP and non-SAP, using Business Object Data Services. Okay, setting up the SLT, then creation of the information, designing and creating the information models like attribute views, analytical views, calculation views for sales, finance, inventory scenarios, and financial reporting. So all these are the different POC projects the student has to work on as a part of this course. So the total course duration is 45 to 50 hours. This is a very advanced level of HANA 1.0 with Support Pack 7 course. So our class next topic in the course in demo agenda is HANA 1.0 with Support Pack 7 overview. So we'll briefly look into HANA product strategy, okay, the product overview. Well, before starting, what is SAP HANA? We'll look into present day scenario, what What is information explosion? What type of challenges the companies are facing? Really challenges related to big data. Well, SAP HANA, high performance analytical appliance, is a technology which allows the processing of huge quantity of real-time data in the main memory of the server to provide real-time results from the transactions. Okay. Why an enterprise requires the HANA? What type of business solution we can expect from this in-memory database, from this HANA appliance? Information explosion. As a result of globalization, the companies started operations in different geographical locations. The data is spread across in different geographical locations in different formats. Like the data is in data marts, the data is in data warehousing application, the data is in OLTP systems, the data is in unstructured format like in spreadsheets, in Facebook, in Twitter, marketing data. Okay, whenever the information explosion like this, what are the challenges, okay, faced by enterprise? The challenges related to complex system landscape, flexibility, as the data volume growing rapidly, massively. So getting the immediate results is very difficult as per the requirements of a business user for the decision making. Other consequences: suboptimal execution speed, lack of responsiveness, user frustration, unsupportable business process, lack of transparency, and need of aggregation, outdated figures, guessing the current situation, and reactive business model, massive opportunities and competitive disadvantages. Whenever the business in present day scenario, we have a situation like this as a result of information explosion. What are the challenges faced by enterprise? Well, the business user required reports and analysis for effective decision making. Expectation to make the decisions in real time at the moment of risk and opportunity. Customers expect business experience to be as satisfying as personal experience. People expect instant correct answers to any business question. So whatever the traditional databases, what are the traditional tools the enterprise is using at this point of time, with this, cost-effective management of large data volume, current and incomplete information, getting immediate answer to any business question for decision making, for analysis is very difficult. How we can overcome all these challenges using SAP HANA as an appliance, SAP HANA as an in-memory database? Well, in traditional computing, this is a CPU. The data resides in the hard drive. The primary persistence of the data is hard drive. And this is the main memory, RAM. In order to process the data, the processor has to read the data from hard drive. It has to load the data to main memory. So hard drive is a mechanical device. In order to read the data, the processor has to perform the I/O operations, which are major bottlenecks in the past, in the traditional computing. So what are the major bottlenecks? In the past, disk I/Os. In SAP HANA, the complete data resides in the main memory. The primary persistence of the data is not the hard drive. Complete data resides in the RAM. The primary persistence of the data is main memory, RAM. From RAM, the data is available for the reporting. From the RAM, the data is available for calculations or computations. In this way, SAP HANA is a in-memory database because the complete data resides in SAP HANA is in main memory. So we don't require any I/O, disk I/Os to load the data from hard drive to RAM for the processing. Apart from this, HANA can fully leverage new software technology innovations, new hardware technology innovations, which makes HANA super duper fast. So your reality with SAP HANA, groundbreaking in-memory innovations, because the complete data resides in the main memory, even real-time access to the transactional data. What is real-time data? Why we require the real-time data? This is a transactional system where the day-to-day business transactions will happen. This can be ERP system or any other application. This is SAP HANA. Then in enterprise, the business users require reports on historical data, reports on real-time data, reports with a combination of historical and real-time data. Real-time data in the sense, once the transaction is saved in the source system, right away the transaction is available for the reporting. Replication of real-time data. So replication of real-time data is possible in SAP HANA using SLT, using Sybase Replication Server, which is one of the data provisioning method, which also be covered in this course. So real-time replication. Once the transaction is available in the source, within the fraction of a second, the data is replicated to SAP HANA so that we can generate real-time analysis as well. And 3600 faster analytics when comparing with traditional databases and traditional tools. So we'll see the brief history about SAP HANA. SAP HANA released by SAP in 2010 November. Support Pack 0, HANA 1.0 with Support Pack 0, which is a HANA first public release. Support Pack 1, June 20th, 2011. Support Pack 2, 27 June 2011. Up to Support Pack 2, HANA, what is the product strategy of SAP HANA is, HANA can be used as a data mart. In the sense, only data mart functionalities. We can load the data from different SAP and non-SAP source system to SAP HANA. We can design the information models. We can start consumption of these information models using SAP BO BA4.0 reporting tools. HANA as a data mart. Up to HANA 1.0 Support Pack 2, what is the HANA product strategy? The client can use HANA as a data mart. In the sense, we can load the data in HANA database tables from different source systems, from different SAP and non-SAP source systems. Then design the information models. Attribute views, analytical views, calculation views, then start reporting using SAP BO BA4.0 reporting tools. This is the HANA data mart functionality. But when SAP released HANA 1.0 with Support Pack 3, the complete product strategy of HANA has been changed. HANA can be used as an underlying database for SAP BW 7.3, but we need minimum Support Pack 5 or higher, also named as a Project Orange. This is HANA 1.0 Support Pack 2. From different SAP and non-SAP source system, HANA has a data mart. We can load the data we can design the information model, start reporting using SAP BO BA 4.2 reporting tools. When SAP released support pack 3, the same HANA can be used as a data mart. The same HANA database can be used as an underlying database to BW 7.3. But we require minimum BW 7.3 with support pack 5 or a higher version. So these are BW with HANA as an underlying database. So whenever we are using HANA as underlying database for BW, it will accelerate the BW performance in ETL perspective as well as in reporting perspective. So we don't require HANA as a database. We don't require BW accelerator anymore. Then support pack 4 released May 2012 and some new features introduced by SAP. Support pack 5 November 2012, support pack 6 2013 and support pack 7 also by the end of 2013. Why SAP released SAP HANA? Where exactly SAP has positioned SAP HANA? SAP released SAP HANA as one of the solutions for the big data. What is a big data? Big data refers to the data sets that exceeds the ability of commonly used tools. While no formal definition based on the size exists, these data sets typically reach terabytes, petabytes, or even exabytes in size. SAP has positioned HANA as a solution to the big data challenges at the low end of this scale. At launch, HANA started with 1 terabyte of RAM, supporting up to 5 terabyte of uncompressed data. In late 2011, hardware with 8 terabyte of RAM became available, which supported up to 40 terabyte of uncompressed data. SAP owned Sybase IQ with its more matured MapReduce-like functionality has been cited as a potentially better fit for large data sets. By May 2012, HANA was able to run a server with 100 terabyte of main memory powered by IBM. So this is a project collaboration with IBM. Okay, SAP built a HANA appliance with 100 terabyte of main memory. Hasso Plattner claimed that the system was big enough to run 8 largest SAP customers. Well, SAP HANA is not first in-memory product of SAP. There are other in-memory products of SAP before SAP HANA also. In fact, SAP HANA is a synthesis of 3 SAP products. What are those? First one is TREX, pstart time, and MaxDB. What is TREX? Text retrieval and extraction is a search engine. It began in 1996 as a student project at SAP in collaboration with DFKA. TREX became a standard component in SAP NetWeaver in 2000. In-memory attributes were added in 2002 and corner data store was added in 2003, both ways to enhance the performance. So first, TREX. From TREX, in-memory attributes, and HANA supports column-based approach. Column-based tables. So column-based table feature is added from TREX because the TREX is completely based on BW accelerator is also based on TREX. Column-based tables, in-memory attributes, and all. Second, pstart time. So what is this pstart time? In 2005, SAP acquired Melanopack-based Transact in-memory (INC). With this acquisition came P-Star Time, an in-memory lightweight online transaction processing (RDBMS) technology with row-based data store also. Complete in-memory based technology in-memory based technology and row-based approach has taken from P-Star Time. Third one is MaxDB. From MaxDB, persistence layer. So SAP HANA is not SAP first in-memory product. Business Warehouse Accelerator, formerly termed BIA, was designed to accelerate queries by storing BW info cubes in memory. So BW is also a kind of in-memory product. This was followed in 2009 by Explorer Accelerator, where SAP combined the Explorer BI tool with BWA as a tool for performing ad hoc analysis. Other SAP products using in-memory technology like CRM segmentation and live cache in APO also in-memory products. So this is one of the research from Gartner. Conventional database disk read is 5 milliseconds, 1 million times faster than disk. In-memory databases disk read is 5 nanoseconds. By 2012, 70% of global 1,000 organizations will load detailed data in memory as a primary method to optimize the BI applications. Like the companies wants to store their data in main memory for their performance. Well, what exactly is SAP HANA? What are the different components this HANA appliance consists of? SAP HANA is a hardware and software combination that includes a number of SAP components, including SAP in-memory database. The core and heart of SAP HANA is SAP HANA IMCE, that is called SAP HANA in-memory database engine, in-memory computing engine. Current version is 1.0, support pack 7. So this is IMCE. Apart from this IMCE, a client tool called SAP HANA Studio and the tools for data provisioning, okay, and the components for SAP BOPI to connect to SAP BOPI. So there are various components that comes along with this HANA appliance. So HANA appliance is available in different editions, like SAP HANA appliance in Platform Edition, Enterprise Edition, Extended Enterprise Edition. Platform Edition is a basic one for customers who already have licenses for SAP Business Object Data Services. Following are the subcomponents: SAP HANA Database, Studio, Client, Host Agent, Information Composer. In Enterprise Edition is for customers who do not already have all necessary licenses for SAP Business Object Data Services. Following are the subcomponents: Database, Studio, IMCE, SAP HANA Studio, other client component, Information Composer, SLT, and Data Services. And this is the Extended Enterprise Edition, where the client will get all the components in Enterprise Edition plus the components to implement Sybase replications technology. Okay, SAP HANA can leverage new software technology, can fully leverage new software technology innovations, new hardware technology innovations, which makes HANA super duper fast. Let's see what are the new hardware technology innovations that HANA can fully leverage. The new hardware technology innovations: multi-core CPUs, 10 cores again in each CPU, multi-CPU boards, 8 CPUs again in each board, multi-server boards into boards, massive memory setups. Starting from 2 terabytes, we can build a HANA appliance with more than 100 terabytes of RAM also. So these type of hardware innovations supported by HANA. That is the reason HANA required latest Intel processor such as Intel Nihilum, Intel Westmail, which makes HANA super duper fast. Apart from these new hardware technology innovations, HANA can fully leverage new software technology innovations, so which also makes HANA super duper fast. What type of new technology innovations that HANA can fully leverage? HANA supports row and column based data storage. If you look at the HANA database tables, so this is a column based table. Apart from the column based tables, SAP HANA supports row based tables also. See, these are row based tables. Now, what is row based approach? What is column based approach? Row based approach. Conventional databases store the records in rows. Storing the data in columns enables a faster in-memory processing of operations such as aggregates. By storing the data in column-based tables, the data is highly optimized for the read operations and the data is highly compressible. Columnar layout supports sequential memory access. A simple aggregate can be processed in one linear scan. Massive parallel processing possible for column also. So these features of column-based tables, the column-based approach is highly optimized for the read operations and the data is highly compressible. The compression factor, for example, if you have 1 terabyte of data in traditional database, same data in SAP HANA using column-based approach is approximately 100 GB. And the partitioning. The data can be partitioned in several plates because we have so many cores, and these cores can process parallelly for faster retrieval of the data. Data distribution, RAM locality. Data gets spread out of all available cores. Failover. Individual blades may fail without causing any problems. So apart from this, using HANA as a database layer, we can push down all the calculation part from the application layer to the database layer. In this way, we can avoid the massive amount of data transfer between application layer and database layer, and application layer does not require more round trips to the database. Whereas if you are performing the calculations in the application layer, so the massive amount of data will be transferring from database layer to application layer. Again, after the calculation, the data has to insert it back to the database. Here, only move the calculation to the database, only transfer the result to your application layer. So this is also one of the features which is available in SAP HANA, okay, which makes HANA super duper fast. So this is one of the POC results because HANA stores the complete data in the main memory. It's a in-memory database, and apart from that, HANA can fully leverage new software technology innovations, new hardware technology innovations, which makes HANA super duper fast. So there are 70 retailers combine the data together, approximately 50 terabytes of data with 460 billion records. Some complex queries are tested. The query response time is 13 seconds with SAP HANA. It was taking 77 minutes before with SAP HANA. And some average queries are tested. The response time is 0.0 seconds. You can, with this POC result, we can imagine what is the performance of SAP HANA. How fast is SAP HANA? SAP HANA is available in different t-shirt size, extra small, small, medium, okay, large and extra large. So extra small 2x8 core Intel Nihilum, 120 GB of main memory. These are uncompressed data. These are the pricing, and there are various certified vendors from where the client can purchase this HANA appliance like IBM, HP, Cisco, Fujitsu, Dell, NEC, and Hitachi. So this is the overview of SAP HANA, a small product overview, and happy learning.
The